And I'm going to go over the intermediate value theorem. This theorem is part of section 1.5. I'll give you the statement of the theorem without proof, and I'll do some examples, okay? Now, the theorem goes, let f be a continuous function on AB if n is a number in between f of A and f of B, then there is a C in AB such that f of C is equal to 1. Okay? That's the statement of the theorem. Now, what does that mean? I'm going to tell you what it means graphically, okay? So suppose that this is the graph of f of x. That's my graph, right? And say this is A and this is B. Okay. If this is A and this is B, then this is f of A there, and then this is f of B. So what the theorem says is that if there's a number in between f of A and f of B that I'm calling n, so say n is it's right here, then I can go back to the function, and find a C such that this is f of C now, so f of C is equal to n, okay? In other words, what this theorem tells me is that, hey, look, if you have a continuous function, right? If you have a continuous function, it'll take every single number in between f of A and f of B. It'll take every single number in between f of A and f of B, right? Think, for example, of temperatures. Think that you woke up this morning and it was like 70 degrees, right? And then now at 2 p.m. is 75 degrees, okay? The only way you can go from 70 to 75 is by going through every single possible temperature, right? So that's what continuity means, and that's what this theorem tells me. Okay, let's do examples. So does f of x equal x to the fifth minus 2x cubed minus 2 have a root in 0, 2? Right? Does it? Well, the very first thing you have to do is to review the definition of a root, okay? So we know that, say, p is a root of f if, when I plug it in, I get 0. If f of p is equal to 0. Okay? So then again, I'm not asking you to find the root. I'm asking you to answer the question, does this function have a root, yes or no? That's it. Okay? So, of course, this is the intermediate value theorems video, so you want to try to apply it, okay? So the very first thing that you have, the very first condition is you need your function to be continuous. So I go, well, my function, it's a polynomial. So we know that f is continuous, right, on 0, 2. For sure, it's a polynomial, okay? Then the next part is, well, if n is a number in between f of A and f of B. So you go back to the problem. Now this is A and this is B. So long story short, if I do f of 0 and I do f of 2 and I get something negative and something positive, since 0 is in between something negative and something positive, then by the intermediate value theorem, there's a C in between 0 2 such that f of C is equal to 0. So let's do it. If I do f of 0, I get that this is 0 to the fifth minus 2 times 0 cubed minus 2, which is negative 2. Okay? If I do f of 2, I get 2 to the fifth minus 2 times 2 to the third minus 2, okay? Which is 32 minus 2 to the 2 cubed times 2, that's like 2 to the fourth, which is 16 minus 2. And this is something positive, but it's 32, 16 minus 2, you get 14. I don't know how to add. Long story short, we got something negative, we got something positive. The only way you can go from negative to positive is by going through 0. Okay? So then I say since, right? 0 is in between -2, which is f of 0, and 14, which is f of 2. Then, by the intermediate value theorem, IVT, there's a C in 0, 2, such that f of c is equal to 0, meaning, yes, this function does have a root in between 0 and 2, okay? Does that make sense? Actually, because of this theorem and because of the continuity of this function, right, f of 0 is equal to, so here we are. I'm going from 0, this is 0, and this is 2, okay? And this function is equal to -2 at 0, so here we go. So -2 right here. And then at 2 is equal to 14. So I'm gonna say it's up here, 14, okay? So I don't know the behavior of the graph, but I know that because of the continuity of the function, yes, there's a c such that f of c it's equal to 0, because you have to go through the x-axis, but there's also a c in between 0 and 2 such that f of c is equal to -1 and 1, 2, 3, 4, and 2.5 and 3.17, and every single number in between -2 and 14. Okay? In this case in particular, we did it for 0 because we were talking about the root. Okay? Perfect. Let's do another one. Does there exist a continuous function f of x such that f of 2 is equal to 1, f of 5 is equal to 10, but f is never 3, okay? Well, this is a continuous function, so I can apply the intermediate value theorem, okay? Actually, the fact that it is continuous, I can just say, hey, it is continuous in between 2 and 5, okay? So let's see. So since f is continuous, you know, in particular, on 2, 5, and 3 is in between f of 2 and f of 5, then by the intermediate value theorem, there's a c in 2, 5 such that f of c is equal to 3, okay? Or 4, or 5, or 6, or any number in between 1 and 10, okay? Perfect. That's it. That was the intermediate value theorem. Make sure that you memorize the statement, and I'll see you next time.